Unit 1, Lesson 10, How Did I Do? Today we're going to be discussing z-scores, and we're going to see how a constant changes the shape of the data if it's added or multiplied to every single point of the data. Okay, go ahead and look at how did I do. And what you notice on here is there's a result of a summary statistics. It gives you data, it graphs it for you, and gives you the summary of the data. So if Biff had a score of 85, what is Biff's percentile? 65. So I look at 65 right here, and I see that 65 has 1, 2, 3 at or below 65 out of 20. So 3 out of 20 is 15%. And so he's in the 15th percentile. Biff was below the mean he was 65, the mean is 80, so he was below the mean by 15 points. So because he was below the mean by 15 points, we know the standard deviation is 10. So he's 1.5 standard deviations below the mean. And as you can see on the left, you can see that this is called a z-score of negative 1.5. And that is he's 1.5 standard deviations below the mean. The z-score is how many standard deviations you are above or below the mean. Okay, so Marty scored an 88. What's Marty's percentile? 16 divided by 20. Why 16? Because you look at 88 right here, and you count all of these pieces of data at or below 88, and you get 16. 16 divided by 20 is 80 percentile. He's above the mean by 8 points because the mean, remember, is 80. So that means how many standard deviations is he above the mean? He's 8 points above. A standard deviation in this case is 10, so he's 8 over 10, or 0.8 above the mean. So my z-score is 8 plus 8, because plus 8 means 0.8 standard deviations above the mean. To calculate the z-score, you're going to take the value. So we had, for instance, 88 minus the mean of 8. 88 is the value minus the mean of 80 divided by the standard deviation we had was 10, and that would get me my 0.8. What about 98? Let's see what that would be. 98 is this one right here. And that was where she found that she is at or above 18 people above the mean. So she was 18 points above the mean. So 98 minus 8 divided by 10 gives her 1.8. So she is 1.8 standard deviations above the mean. Okay, there are two mathematical operations when calculating a z-score. First of all, of course, we're subtracting the score minus the mean. And here's the score. If you go ahead and make a dot plot for the score, you're going to see that this is the score. Now watch what happened, the dot plot for the score minus the mean. I have identical dot plots here. The only thing that happened, look here, guys, this is 80 and this is 0. Because what I did was I graphed the score on the left, I subtracted the mean was 80, and that's why 80 minus 80 got me 0. And if you notice, my shape did not change when I subtracted. So what happens to the shape, center, and variability when you subtract from the mean? The shape stays the same. The center, you can see, moved from 80 to 0. So it moves down how much ever I'm subtracting. The mean was 80, and now the mean is 0. So the mean moved down the amount that I subtracted. The variability is the same. Look here. We have 99 minus 61, and now I have 19 minus negative 19. And if you notice, that distance is absolutely the same. You can see that the mean, I had max minus the min, was going to be identical to the max minus the min when I subtracted the data. So now let's go ahead and do the score minus the mean, which we have, and divide it by the standard deviation. So this is my z-score, and now we're going to do a dot plot here. So if you notice, what happens is that the distribution looks the same. It's dots in here, but if you notice, there's something that's changed just a little bit. And when we divided it, we have our distribution of z-scores, and you can see now it's between -2 and +2. So my variability is only 4 or less than 4, and before it was close to 40, because look, it was between 60 and 100, a little less than 40, between -20 and +20, almost a little less than 40. And now it's between -2 and +2, so 40 divided by 10 is 4. So you can see that because I divided this by my standard deviation, and my standard deviation was 10, that divided my range also by 10. You can see the shape stayed the same. The center stayed the same when it went from 0, still at 0. So, but it's because I divided by 10. 0 divided by anything is 0. So that's why it stayed the same, but it actually did quote unquote change. My variability did decrease by a divisible by 10. So let's summarize what happens to my shape. When I subtract a value, my shape stays the same from here to here. The center stayed the same when the center added or subtracted by that value. It subtracted for us by 80, so we got 0. And then my variability stayed the same. It was about 40 before, it's about 40 after. When I multiply or divide, you saw that the shape stayed the same, but the center divided by that value that I divided by or multiplied by, and the variability also divided or multiplied by it, the same value. The mean and the standard deviation, the distribution of z-scores, is true for any distribution of z-scores, and it's always going to be, with my z-score, my mean is always going to be 0, and my standard deviation is always going to be 1. The reason being is because I'm taking the mean, the value minus the mean, and so you notice that's the mean minus the mean, and that's always going to be 0. So that's why my mean in my z-score model is going to be 0. So we have a standard deviation, and for the standard deviation, same thing. I have standard deviation minus my mean divided by standard deviation, and that's standard deviation divided by standard deviation is going to be 1. So the learning target number 1 is your standardized values or your z-scores. You have your z-scores, your value minus your mean divided by your standard deviation, and your context is your z standard deviations above or below the mean. So you would say, we were talking about test scores, my test score is 2 standard deviations above the mean or 4 standard deviations below the mean or whatever it is, and that's how you would interpret the value of your z-score. In any distribution, if I add or subtract something to the data, everything's going to be shifted up or down, but the shape itself and the variability itself is not going to change. If I multiply or divide, however, it's going to be multiplied. My variability is going to be multiplied or divided, and also my center is going to be multiplied and divided. For checking for understanding, let's go ahead and see here. For this here, my transformation, as you can see, I'm dividing by 7. So my shape is going to be the same shape. It's just going to be divided by 7. So it's still the same. It's still going to be skewed to the right. You can still see it, but it's going to be every single number on there is going to be divided by 7. For the next one, it's going to be subtract by 1, which means everything's just going to shift to the left. So the shape stays the same. The mean shifts 1 to the left. So everything's going to shift 1 to the left. My standard deviation, which means the average distance my dots are from the mean, it's not going to change because that's my spread. And it's just shifting. The spread is not changing one way or the other. Finally, for the last one, I'm going to subtract and divide. So everything that changed when I divided changes, and everything that changed when I subtracted changes. So some of them, like the shape, it stays the same. Shape doesn't ever change when I'm doing transformations. My mean does both. I subtract and then divide, and it changes both times. My standard deviation, though, because it's my spread, it doesn't change when I shift everything, but it does change when I divide. So that's just going to be divided by. And all standardized distributions, remember, have a mean of 0 and a standard deviation of 1. All right, thank you for listening, and I'll see you next time.